We're going to do some mole to mole ratio practice problems. So we have an example here. Lead will react with hydrochloric acid. So here's our reactants, lead plus HCl, to produce lead chloride, so PbCl2, and hydrogen. So in order to do this, the first thing we need to do is we need to balance the reaction. So we're going to need a coefficient of 2 here. Once we have that, we can look at what we are given, which we're given 0.36 moles of lead. So that's what we're going to start with, is 0.36 moles of lead. And then we're going to create our conversion factor. Each of these tells us how many moles of that material we need. So we need 2 moles of HCl, which is what we want to figure out. We want to figure out how many moles of HCl we need. We don't want to have moles of lead anymore. So since the reaction tells us 1 mole of lead reacts, that's what this tells us right here, there's no coefficient in front. We don't want moles of lead anymore, so that's going to cancel out for us. So we are now going to have our answer in moles of hydrochloric acid because our chemical reaction, the coefficient in front, tells us how many moles of hydrochloric acid we need. So now we're going to do 0.36 times 2, and that's going to tell us how many moles of hydrochloric acid we need. Now, the ratio method, the proportions method is shown set up here. No matter which way you do it, you're still going to get the same answer. You're still going to get 0.72 moles of HCl. So the first thing we need to do is we need to write the chemical reaction correctly. It says how many moles of nitric acid will be produced in a synthesis reaction when 0.5 moles of dinitrogen pentaoxide reacts with excess water. So my first step is going to be writing my chemical reaction correctly. So we've got dinitrogen pentaoxide reacting with water to produce nitric acid. Now, before I can do anything, I need to balance this chemical reaction. And balancing this, all I need to do is put a 2 in front of my nitric acid. I will have 2 hydrogens coming in and going out. I will have 2 nitrogens going in and coming out. And I have 6 oxygens going in and 6 oxygens coming out. So now I am ready to solve my problem. I'm going to start with what I'm given. I'm given 0.510 moles of dinitrogen pentaoxide. And the question is, how many moles of nitric acid will be produced? So I want to know how many moles of dinitrogen pentaoxide, and I'm given my moles of dinitrogen pentaoxide. So I can create a conversion factor from the balanced chemical reaction. I don't want moles of dinitrogen pentaoxide anymore, so it's going on the bottom. I want to know how many moles of nitric acid are going to be made. So remember that the balanced chemical reaction tells me how many moles. I have 2 moles of dinitrogen pentaoxide. There's no number in front of, of nitric acid. There's no number in front of the dinitrogen pentaoxide, so I have 1 mole, so it's a 2-to-1 ratio. So all I have to do is 0.510 times 2, and I will get an answer there. I will also show real quick the proportions method. So I do have the setup for the proportions method in blue. Cross multiply, 1x is just x, cross multiply, and you'll get the same answer. So there's our answer, 1.02 moles of HNO3. We've got 2 more problems on this. Feel free to pause it and try it on your own. First step is going to be writing the chemical reaction and then balancing it, and then we can finally solve the stoichiometry involved. So you can see that I started with my balanced chemical reaction. It says carbon will react with zinc oxide, and it's going to produce zinc and carbon dioxide. It's not balanced. I'm going to need a 2 in front of the zinc and a 2 in front of the zinc oxide. So I'm going to start with what I'm given. I'm given 0.38 moles of zinc oxide. So that means that my moles of zinc oxide is going on the bottom because I don't want that anymore. And so I'm going to be looking at the zinc oxide, and I can see that for zinc oxide, it says 2 moles here of zinc oxide are going to be reacting. So I'm going to put a 2 down there. Then I'm going to look and see what it wants me to find. It wants to know how many moles of carbon dioxide will be produced. So I'm going to look over here at carbon dioxide. I see there's no coefficient in front of it. So that means that there's 1 mole of carbon dioxide being produced. And now I'm ready to solve the problem. I will show real quick the proportion cross multiply method. So over here in blue, you would have to cross multiply. 2 times x is 2x. Is equal to 0.38. You need to divide both sides by 2 in order to find and solve for your x, which is the same math that we do with our ratio method here. So you should get 0.19 moles of carbon dioxide. Again, try and pause it and try the next problem on your own before going on and watching me do it. So you can see I started with my balanced chemical reaction. This is a single replacement reaction. And if I read my problem, I can see that it wants to know if I am using 0.69 moles of bromine. It wants to know how many moles of sodium bromide will be produced. So I'm going to start with what I'm given, 0.69 moles of bromine, and I don't want moles of bromine anymore, so I'm going to put it on the bottom. According to my balanced chemical reaction, I just need 1 mole of bromine because there's no coefficient in front. So 1 mole of bromine. And according to my balanced reaction, I need 2 moles of sodium bromide to be produced then. And I get that from my chemical reaction coefficient right here. I will show in blue real quick the cross ratio. So I have the other method in blue right here. Again, you have to solve for the x, but no matter what, you're going to get the same answer. You should get 1.38 moles of NaBr are going to be made. Again, now is a good time to pause the video and see if you can do some of these on your own. So the first thing you can see that I did is I wrote out my balanced equation. I identified what I'm given, which is 0.78 moles of bromine, and I identified what I want to find. So I start with what I'm given, 0.78 moles of bromine. I don't want moles of bromine anymore, so I'm going to put that on the bottom, and I'm going to look at my balanced equation to see how many it says. It says 3 moles. So according to my balanced equation, I need 3 moles of bromine to react, and when that happens, we're going to make 2 moles of phosphorus tribromide. So that's what's going to go on the top is my 2 moles of phosphorus tribromide. Now I can go ahead and solve. I did go ahead and put in blue the cross multiply and solve for x method. No matter which way you use, you should still get the same answer of 0.52 moles of phosphorus tribromide. On the next problem, it gives me the balanced chemical reaction, so I went ahead and wrote that out. I'm going to identify what I'm given. I'm given 0.44 moles of calcium hydride, so 0.044. And I want to know how many moles of hydrogen are going to be produced. So I've got my work shown here for starting with and multiplying by our ratio, 2 moles of hydrogen over 1 mole of calcium hydride. I also have in blue the cross multiply and solve for x. Either way you do it, you should get the same answer of 0.88 moles of hydrogen are going to be produced. Again, if you haven't tried to do any on your own, pause the video now and try to do these last 2 on your own. So this first one is a combustion reaction of a hydrocarbon. So you can see I've got the equation written out, but I do need to balance it. So now you can see I put in my coefficients to balance it. I'm ready to start with what I'm given. So I'm given 0.38 moles of C3H8. So that's what I'm starting with. I want to find how many moles of oxygen. So I'm going to look at my balanced equation and see that it tells me 1 mole of C3H8 because there's no coefficient in front. So that's going on the bottom so that moles of C3H8 cancel out. I'm going to put what I want to find on the top, which is moles of O2. According to my balanced equation, it says 5 moles of O2, and then I'm going to solve for the reaction. I did put the cross multiply and solve for x method over here. No matter what, you should get the same answer, 1.9 moles of oxygen. First step is always to start with your balanced chemical reaction. So I'm going to start with what I'm given, 0.48 moles of NH3. So that means that I'm going to put my moles of NH3 on the bottom. According to my balance reaction, there are 2 moles of NH3 that are needed in this. And then I'm going to put what I want to find on the top, which is moles of N2. And according to the balance reaction, it's just 1 mole of N2. And then I'm going to solve. No matter which way you solve it, which I do have the other method in blue over here, you should get 0.24 moles of nitrogen.